All right, so a reminder that the central angle equals the intercepted arc measure. That is something that's very important that I believe you should highlight so you know, because this is something that you're going to need as we solve circle problems throughout this unit. So in number 5, we are going to determine a few things. The first is the measure of arc CE. So they're talking about this one. So I need to add the 53-degree angle plus the 34-degree angle, which is 87 degrees. And just to clarify, because we didn't really talk about this, half a circle is 180 degrees, but a full circle is 360 degrees. So keep that in mind as we go throughout. So now I want the measure of arc EF. So this whole half circle should be 180 degrees. So if I do 180 minus that 87 degrees, because I already added the 53 and the 34 together, I get 93 degrees for EF. Now I want the measure of arc ECK, which is this arc here. Well, if we look at the other half of our circle, that's 180 degrees. And since arc CH, HK, and KF are congruent, if I just do 180 divided by 3, that means that all of these are 60-degree arcs. So, starting at EC, that was 87, plus CH is 60, plus HK is 60. That brings me to the end of arc ECK, that's 207 degrees. And then, lastly, I want arc DFC. So D to F to C is this. Sometimes it's just easier to do, instead of adding out all these arcs together, a full circle is 360 degrees, and I can subtract this little portion that's not included in my arc, 53, and I wind up with 307 degrees. You could have found that also by adding up all the arcs that I highlighted in red. All right, so we're given circle B with EC as our diameter. We want the measure of arc AC. Well, we have angle ABC, which intersects arc AC, and that's a central angle. A central angle is congruent to its arc, so this is also 39 degrees. So arc AC is 39 degrees. Whoa, that's a big degree symbol. Okay. Now, we see that arc AC and arc DK are equal, so this is also 39 degrees. And this whole arc is a semicircle, so that's 180 degrees. So if I do 180 minus 39 minus 70, that leaves me with arc EK being 71 degrees. So now it's asking for arc AE, which is this one here, which finishes off my full circle. So if I do 360 minus 39 minus 70 minus 39 minus 71, I get that arc AE is 141. Or I could have just did 180 minus that 39 degree angle, since arc EC spans a semicircle. It's up to you. There's many ways to do these problems. All right, arc EK, we already found it. That's 71 degrees. And now they're asking for angle KBD, which is a central angle that intersects arc DK. And since arc DK is 39 degrees, that means that angle KBD is 39 degrees. the central angle is equal to the arc that it intersects. All right, so for this one, we have a regular hexagon. So actually, if we know that we're dealing with a regular hexagon, hexagon means 6 sides, then that means that we can find our angles within our hexagon. We can find these angles here. These angles here create a full circle, which adds to 360. So 360 divided by 6 leaves us with these angles being 60 degrees each. So all these central angles are 60 degrees. And then in addition to that, let's look at this triangle here. ET and TD are congruent because they are both radii. And we know that in isosceles triangles, base angles are congruent. So if I do 180 minus 60 divided by 2, I actually get that these angles here are 60 degrees, which doesn't even make this isosceles, it makes it equilateral. So all of these angles are 60 degrees as well. And all of these are equilateral triangles. I'm going to refrain from actually doing the rest because we're going to talk about that. So I want the measure of angle ATB. ATB is this central angle here. That's 60 degrees. And then I want the angle DTB, which is this angle here, DTB. So if I add the two 60-degree angles together, I get 120 degrees. And then now I want the arc AC, which is this arc here. Well, I have each of these central angles being 60 degrees, so each of these minor arcs are 60 degrees, because remember the central angle is equal to the arc that it intersects. So if I want arc AC, that's a 60 plus a 60, which is 120. Now I want the measure of arc ECA, so going from E to C to A, that is 1, 2, 3, 4 60-degree angles. So 60 times 4 is 240 degrees. Now I want the measure of angle AEB. So that's actually this angle. Okay, which we don't have, so we're going to talk about it. Now, if all of these are equilateral triangles, that would mean that ET is a radius and AT is a radius. So this green triangle is an isosceles triangle, so base angles are congruent, and the vertex angle is 120, 60 plus 60. So if I do 180 minus 120 and then divide by 2, I get that each of these angles are 30 degrees, which means that angle AEB is 30 degrees. Now, if AB is 5 centimeters, what is TB? Well, again, we talked about these being equilateral triangles, so TB would also be 5 centimeters. And now they're asking if AB is 5 centimeters, what is EA? So EA is this that I'm highlighting in black right now. We are going to use this right triangle to help us figure it out. We have AB being 5, TB and ET are both 5, so this is a length of 10. And now I can use the Pythagorean theorem to find EA, which I'm going to label as x. So if I do an x squared plus a 5 squared, that should equal to 10 squared. This is not a Pythagorean triple, so we would actually need to do this work. So I have x squared plus 25 is equal to 100. Subtracting 25 over, I wind up with x squared is equal to 75. And taking the square root of both sides, let's find the exact value. So when I say exact, that means simplest radical form. So I need to find the largest perfect square factor of 75, which is 25. A 25 times a 3 is a 75. And we can do the square root of 25. The square root of 25 is a 5. The square root of 3 cannot be done. That remains. 5 root 3 is your measurement for EA. All right, so this brings us to the end of this lesson. We talked about, again, how central angles are equal to the intercepted arc measure. A full circle is 360 degrees. Half a circle is 180. And then, same thing here. To find these angles here, we just did a full circle of 360 and divided it by 6 since there were 6 angles here. So use this information along with the vocabulary words to start your practice.